Good morning once again. We are discussing this one now. Okay. So here it is a one-way slab bending in only in one direction. Here the bending is both directions. Okay, both directions. So one-way slab, two-way slab. Okay. So again steel is made like this. Steel is placed like this. This is main steel, distribution steel. Here both sides main steel. So why this bending is shown here? This is called as cranking of the bar. Okay, cranking of the bar. In the previous diagrams you have seen, no, in the cross section like this it will go and bend like this. Like this it will go and bend like this. So those bendings are shown here. Okay, so like this bendings are shown like this. These are called as cranking of the bar. Okay, so here once again. So in the text, in this diagram, how I have marked, okay, like this I have marked. Okay, you should draw diagrams like this. Okay, so here you can see the small arrow mark like this. This resembles one way. If arrow mark is both sides like this, okay, this is called as two-way slabs. Two-way slabs. Okay, so bending only in one direction. Here bending is happening in two directions. Bending is happening in two directions. So that is why, so here also I have shown bending, here also I have shown bending. So this will be your mark for two-way steel. So here both main steel, both are main steel. Okay. Okay. Now next we will go to the simple RCC slab. Okay, before going that one, how to write this one-way slab and two-way slab? If L is greater than 1.5 B. B is width of the room, L is the length of the room. So here we generally LX we write, here we write LY. Both are same. Okay. So then it is called as one-way slab. One-way slab. For two-way slab, L should be less than or equal to 1.5 B. L is less than or equal to 1.5. Very important terms to differentiate one-way and two-way. One-way and two-way. Now we have started with the discussion on what simple RCC slab. See, okay, what is actually happening? This is the brick wall. Try to imagine. I will show the correct diagram how it will appear in the site. Okay, first imagine. This is another brick wall. Simple means what? It is resting on wall directly. There are no beams, there are no columns to support the slab. So slab is directly resting on walls. So the walls will be called as load bearing walls. Load bearing walls. Here simple RCC slab means whatever the slab is there, no, it is directly resting on the wall. Directly resting on the wall. I hope it is now clear now. Now what are the important points? So the slab is inserted inside the wall. Do you agree? This is called as bearing. It's called as bearing. Again, when you see the cross section, this is the typical slab section. So here at the bottom you have main steel and this is called as cranking. Correct, no? If something is bent upward and taken to the supports, that is called as cranking. Why? To avoid bending of the B slab like this. Otherwise what will happen? If you take a thin paper, if there is a two supports like this, two pen you keep like this, after pressing here at the center, means applying some load, how it will bend? At the center it will bend like this. Everyone knows this one. Okay, so that is why main steel is provided at the bottom. Okay, here main steel is provided at the bottom. Okay, that is one thing. What will happen near the supports? It will go and bend like this. No, you should check this one. It is going and bending like this. It is not here only, it is ending. For this type of bending, again the tension will be at the top here. Here also the tension will be at the top. To counteract this one, you require some steel, no? So that is why these bars are bent like this, which is going near the top. That's all, which is going near the top. Other places, all the bars are at the bottom only. Only near the support, some bars are taken and bent like this. Some bars are taken and bent like this. Once the slab is there, you have what? Flooring or tiles or covering. Anything you want to have. Okay. So now, how it is appeared inside? Can you remember the name? Slab is directly resting on walls. Okay, so just I will see the diagram here where it is. Yes, can see the, I will make it smaller. Yes, this is the diagram. Here there is no columns, no. Directly on the walls, the slabs are there. On the walls, whether you can see any column, any beam, nothing, no. So all this is load bearing wall. So the directly this slab is placed here. Okay. So steel bars are inside, running like this, everything is inside. Okay. So near the supports it is bent like this. Near the supports it is bent like this. Okay, this is the simple RCC slab resting on the brick wall. Next category, I will just check this one. Next category, brick slab. Here reinforcement is also there. Bricks are also there. How you should understand this point? Okay, so reinforcement means steels is there. Reinforcement means steel is there. In this direction also, in this direction, these are the steels. These are the steel. Okay, both way steel is there. And there are bricks also. There is bricks also. These are what? Bricks. What are these? One brick, two brick, three brick. These are bricks. So wherever the gap is there, you are filling with the mortar. You are filling with the cement mortar. Okay, na? So there is a brick, there is a steel, and there is a mortar. So this is called as reinforced brick slab. Why it is used? You should understand which is cheaper. Brick is cheaper, or if you put total concrete it will become cheaper. One side you have brick plus mortar plus steel. Another side concrete plus steel. Which will be cheaper? Obviously, when you use bricks, no, it will be cheaper. Okay, concrete is costly. So to have less cost, you are using bricks instead of concrete, and again you have steel. How these things will appear? Okay, how these things will appear in the site? Just check this diagram. Yes, reinforced brick slab. I hope now it is clear now. Very clear. Okay, so bricks they are going to keep, steel bars they are going to put like this in this direction. So later on they are going to put the mortar or concrete, anything. But this much of concrete is saved, no? This much of concrete is saved. Okay, but it is not so strong. Okay, but still it can be used to have what is that? Cheap, to have less cost. So this is called as a reinforced brick slab. Here bricks are also there, and reinforcement in the form of steel is also there. So everywhere it is binded using binding wire. It is binded, and later on it is going to put. So here you should understand, whatever the compression forces will come, no, it will be absorbed by brick and this concrete. Wherever tensile forces will be there, it will be absorbed by steel. Like this you should understand. So concrete bricks are good in compression but poor in weak in tension. But steel is good in both compression and tension. Okay. So wherever the joints is there, it is filled with this one. But these are not strong for heavy loads. It is going to collapse. Okay. So now here come back to this diagram. It is the reinforced brick slab. So in exam you should draw this diagram. That is why I am showing everything. Okay, I am showing this line diagram or schematic diagram, which is helpful to draw in the exam. This diagram, practical diagram, to make you understand better. That's all. Okay, this you cannot draw in the exam. Okay. Now next is beam slab. In your house, in the college, wherever you go, no, whatever the slabs are there, those are called as beam slabs. So why? Slabs are resting on beams, beams are resting on columns, like this. First there will be slab, okay, like this. So to give the support to the slab, you have beams in this direction, no, like this. Underneath there will be beams, maybe like this also beams will be there. All the beams will get support from what? So the beams will be standing on columns. So this type of structure is called as a framed structure. Here we are going to study as it as beam slab. It is called as beam slab. Okay. So first was simple slab where no bricks, no beams, no columns, directly on the wall. Here wall will not carry any load, it will act as only partition wall. Okay, so loads are transferred using beams and columns. Now can you see here plan? So outer is the main wall, outer side is the main wall, so sorry, main beams. So inner is the distribution beams, these are called as beams. Okay, main beam, secondary beam, everything will be like this. Now reinforcement will be like this for that one, for slab. So we have seen the previous diagram, no, how that deep was there to have a concrete, okay, beam. I have shown in the shuttering, no, first slides. Okay, try to remember that one. This is the typical diagram, sectional diagram showing reinforcement for beam slab. So you have formwork like this, or the base is like this. Okay, so you have steel, main steel, cranked steel. These dots are nothing but distribution steel or secondary steel or main steel itself. Okay, because if it is a two-way, then both way steel are called as main steel only. Now what is this? This is the section for beam. This is the section for beam. Beam cross section appears like this. Okay, beam like this. Main bars. These are called as stirrups. These are called as stirrups. Okay. Now this beam slab, how it will appear inside? How it will appear inside? Just can we go? Okay, where is that? Here. This is the beam slab. Okay. After construction, okay, after construction of the beams, slabs, columns, so this is the slab, sorry, this is the beam. Beam is supporting what? Slab, no? So here also beam is supporting slab, beams are supporting slab. So beams, and here what is this? Columns, big columns. So here this is also one beam, this is also one beam. So it is forming a grid pattern. It's forming grid pattern. So columns will support beams, beams will support slabs. So this is called as a beam slab construction. You have beams here. Okay. So can you see in this diagram? More clarity is there. More clarity is there. So you have columns. Sorry. You have columns. Okay. So columns are supporting beam. This is a main beam running directly over the columns. So wherever columns are there, this beam is continuously running. But to and this is called as secondary beam. Just to understand, secondary beam. So above this slab is going to come. Above this slab is going to come. So this is used when hall is very large. Hall is very large. Okay. Now next is what? Flat slab. What do you mean by flat slab? When the slab is directly resting on column, there are no beams, no? Any beams are seen here? Can you see any beams? No, nothing. No beams at all here in this construction. Okay, so that is why we call it as a flat slab. No beams at all. Directly slab is casted upon columns. Okay, so these are called as column heads. Small is there, no? These are called as column heads. Okay, so what is the advantage here? Construction is very fast and reinforcement consumption is less, and you get more height for headroom. Okay, so here can you see here, no? Here height is less here because some persons are very tall, no? So to avoid that one, okay, you are going for flat slab. Here headroom availability is less. Okay, because the beams will come. Here the headroom availability is more. Okay, you can directly get this one. So much of height is there. Okay, so that is the advantage. For aesthetic purpose also it is very beautiful. Okay, attractive appearance, aesthetic appearance, everything. Okay, these are very good in fire resistance. Fall ceiling work is not at all required. Directly you can place the things here. Okay, construction is also easier. And total weight of the slab is also very light. Total weight is also very light. Okay, so it's very attractive nowadays. This is isometric view for flat slab. Isometric view for a flat slab. Okay, so these are called as a column head, column drop. Okay, like this, column head, column drop. So this is total slab itself. There are no beams. there are no beams. Okay, this is another site diagram. Okay, flat slabs. Can you see any diagram, anything, any beams? No, only column slab, only column slab. So you get more height in between the floors. Okay, this is also another flat slab. This is also another flat slab. Okay, now one more type of slab is there. What do you mean by that one? Hollow tiled or ribbed slab. Hollow tiled and ribbed slab. So you have some reinforcement in this direction like that, and you are putting some tiles. You are putting some tiles which have hollow sections. Very attractive, no? What is the purpose of making this hollow? To save the concrete and to save the material and to reduce the weight Very beautiful idea, no? So hollow tiles will reduce the material quantity, total slab weight is reduced, dead weight or whatever the weight, and in between you have what is that, steel reinforcement. Okay, so this is another view. This is another view of hollow tiled or ribbed slab. Hollow tiled or ribbed slab. So this is the reinforcement here. This is the reinforcement. But load carrying capacity is less. Load carrying capacity is less. How it is appearing in this diagram? How it is appearing? Okay. So this is that reinforcement diagram for flat slab. We have completed now. This one is completed. Okay. Hollow or ribbed. Hollow or ribbed. Okay. So now in the cross section it appears like this. Correct now? So these are the hollow ribbed tiles. Hollow ribbed tiles. Hollow ribbed tiles. And you have steel. Whether the same thing is there here? Yes, correct. Exactly same site thing is there. Okay. I hope it is very clear now. Okay. It's clear. Okay. What is the advantage here in this hollow one? What is the advantage here? Okay. So material is saved first. Okay. So only tension is carried by steel, not by concrete. Okay. So total concrete is removed where in the bottom section. Only at this top cover it will appear. Top cover and this gaps. Okay. So much of concrete is saved here. Okay. So apart from that, one more concept is left in this module. Okay. So here, how the drainage should be done. So drainage is what? Providing sufficient slope in one direction and collect the rainwater through some pipes and it is disposed of. Okay. So rainwater continuously should not be stagnant on the surface. So that is why to collect that one slope is provided. Second is continuous running gutters or small pipes to collect that rainwater is very important. And disposed, what is that? So what is this? Gutters? Small pipes are there, open pipes. So whatever the rainwater is there, it is disposed. That is one thing. Another very important thing is waterproofing this one. It is very important. We should waterproof. Otherwise, what will happen? Maybe pipes of this may get blocked. So water will not be disposed of. So time water will start making a pond like a structure. To avoid that one, you should also have a waterproofing membrane. How we can do? Proper finishing, very smooth finish so that water will not penetrate. Sometimes you can go for tiles also, flooring tiles also you can go. Some bituminous products will also come, bituminous products. Okay, you can apply that one. Sometimes you can go for Dr. Fixit chemicals. So all those things can be applied. Okay, so sometimes you can go for special paints. Okay, so slurry can also be used. So waterproofing and rainwater drainage, these are very important. These are very important. So that is why those points I have discussed here. Okay. So here. So what are those? Drainage of that flat roof and also this waterproofing. Here you can see